Oh dear. So we have intermediate value theorem. Intermediate sounds like what? Middle, I agree. Does that mean it has to be exactly in the middle and always in the middle? It could also be in between, anywhere in between. So today we're looking at IVT, hence the intermediate value theorem. So go ahead and read the box to your neighbor. Go. Read to your neighbor.
There's no more paper.
What kind of paper?
Back there. Where do we have it?
Oh, it's because we had it last week. I can give you one. Got it. All right, let's look at this graphically. Let's say I have a graph that is continuous from A to B. And I have some point A to B. Oh, I should have had it a little bit higher. Silly me. Let me modify this graph so it matches my f of B to B. Something like this. And if I tell you K is between f of A and f of B, then that guarantees there's also a C value between A and B. That is all that this is trying to tell us. And that's a K, by the way. So let's go ahead and apply this theorem on example number 1. So Logan, let's read number 1, please.
Verify that intermediate value theorem applies to the interval and find the value of C guaranteed by a theorem.
So if it's saying that verify to use the intermediate value theorem, we have to use a bullet point. The first bullet point is it has to be continuous, and you must state that, okay? That would be a point typically on the AP test. So let's write on here, f of x is continuous on, is the interval given on this problem? Yes. Yes, and you'll just repeat that. It's an easy pointer right there. 5 5 to 4. Will you write it on your paper? Because these are hard to type on the computer.
You can do it.
Okay.
I'm used to this.
The next one now says, go ahead and test the 2 points. So our 2 points are 5 half and 4. So f of 5 half is equal to. Let's plug that into our equation given. So I have 5 over 2 all squared plus 5 over 2 all divided by 5 over 2 minus 1. And here's where it's going to get tedious and the silly mistakes would happen. If I take 5 half all squared, it is 25 over what?
4.
Over 4. Now, because I'm thinking ahead, can I go ahead and put 5 over 2 as 10 over 4? Because we need a common denominator. So we have 10 over 4. What is 5 half minus 1? 3 half. Very good. So if I go ahead and combine the top, we get 35 over 4, but I want to do one more thing. When I have a fraction over a fraction, what do we multiply by? The reciprocal. So why not go ahead and do that at once? Now you can go ahead and multiply straight across, or say 2 over 4 is 1 over 2, and make our numbers smaller. So when I do, I get 35 times 1 is 35. Then what is 2 times 3? 6. Let's write this in a mixed fraction just because a whole number in the partial makes a lot more sense. This would be 5 and 5 over 6.
Oh.
Now let's plug in our second value of 4. So we have f of 4. Plug that in with the partner. It's a prettier number.
You have to make that a mix. 6 and 2.
F of 4.
Yeah,
F
that's
of
right.
4, okay.
Do we all get 6 and 2/3? So let's see if the intermediate value theorem is true. Is the value of 6 between these two numbers? Yes, it is. So here's our conclusion. Let's write on here, as a function notation, 5/2, f of 5/2 is less than 6, which is less than f of 4. And specifically, those values were 5 and 5/6 is less than 6, less than 6 and 2/3. So we're allowed to say, therefore, the 3 dots, by the intermediate value theorem, IVT, and we are going to restate the problem given from the original, all of that, the interval and the value. So that's going to state, by the intermediate value theorem, f of c must equal 6 on the interval given, 5/2 to 4 inclusive. And I guess this one was a little bit harder because it had a fraction. The next one will not have a fraction. All right. Let's go ahead and read the next piece to your neighbor. Go.
And f of a is f of b different size, then the intermediate value theorem guarantees the existence of at least one zero on line AB. That is how that is. Values.
All right, let's simplify what you just read. Y'all ready? Okay. So I'm going to simplify it with 3 characters. If I give you a negative number and I give you a positive number, is there a guarantee that 0 has to be somewhere in between? That's all you read. Okay? I'm going to always simplify it, but I do want you to read at the same time. All right? So then on number 2, Mitchell, let's read.
The IVT can be used to locate zeros of a function that's continuous on a closed interval. Oh, my bad. Use the IVT to show that f of x equals x cubed plus 2x minus 1 has a 0 on 0, 1.
So it must have a 0. So it says to use the intermediate value theorem. So the first thing that we have to state is that the function is continuous. So we have f of x is continuous on, what is the interval that they gave us? 0 to 1 inclusive. The second thing that we need to do is plug in what 2 numbers? F of 0 and f of 1. So go ahead and plug those 2 numbers in. At f of 0, what is the value?
-1.
-1. How about f of 1? 2. So, between 0 and 2, is there a 0? Not 0 and 2. Between -1 and 2, does our 0 exist?
That is correct.
Yes, it does. So our format is f of 0 is less than 0, less than f of 1. And specifically, the values that we found were -1 is less than 0, less than 2. Therefore, by what? By IVT. And I'm going to go ahead and write out the given information. There must be a 0 on that specific part. By IVT, we have f of x has a 0 on the interval of 0 to 1. Ooh, that's a bracket. Okay, good on that one? Okay, let's go to the last question. The last question is an actual AP question, AP test question from a free response. Hayden, let's read.
The functions of f and g are continuous and g is strictly increasing. The table to the right gives values of functions at selected values of x. The function h of x equals f of g of x minus h.
So we have composition of a function over here, but the nice thing is we have the table. The tables are always easy to use. So the first thing that I need to state is what? That the function is Now, for the function, am I writing f of x, g of x, or h of x? H of x as a whole, the whole function is h of x, is continuous on the interval 1 less than s less than 3. If you want to write that as an interval notation, you can, but I would avoid it. Just kind of copy what is originally stated. On the next one, we have h of 1 plugged in and h of 3. So I'm going to show h of 1 first. Let's go ahead and plug them into our f of g of whatever. So we have f of g of 1 minus 8. And let's start from the inside. The inside says when x equals 1, which is right here, what is our g? 2. So I have f of 2 minus 8. So now I have when x equals 2, what is our f? 9. So I then have 9 minus 8 is how many? 1. Everyone okay with that? Let's follow that for for h of 3. Go. With the partner.
Minus 8. I did that right.
Yeah, negative 6.
That sounds right.
Should have gotten negative 9. So let's compare. Is negative 5 really between 1 and negative 9? Or I should say negative 9 and 1, and that is true. So let's write this as h of 3 as less than negative 5, less than h of 1, and specifically, negative 9 is less than negative 5, less than 1. And that is true. So therefore, by what?
Oh.
By IVT. And I'm just going to copy word for word and restate. There must be a value s between 1 to 3 such that h of s is equal to negative 5. That's an s right here. That's a negative 5.